pumping lemma, which is used to prove that language is regular or not. Suppose we have language 0 to the power n power of 2. Then what will be the language? The language will be 0 0 0 0 0 0 or 0 0 0 0 0 0 0 0 and so on. So let n is equals to 8, then omega string will be 0 0 0 0 0 0 0 0 and suppose x is equals to 0 0 and y is equals to 0 0 0 and z is equals to 0 0 0. Then x y to the power k z will be equals to 0 0 0 0 0 power k 0 0 0. So if k is equals to 1, then 0 0 0 0 0 0 0 0 belongs to that language, and if k is equals to 2, then what would be the language? 0 0. Here k to the power 2, then 0 0 0 0 0 0 and this is set 0 0 0. Is this belongs to that language or not? No, this is not belongs to that language because it doesn't comes under power of 2. So this does not belong to that language. So language is non-regular. Now move to the next. Suppose if we have 0 to the power n, where n is a prime number, then what will be the language? The language will be 0 0 0 0 0 0 0 0 0 and 0 0 0 0 0 0 0 and so on. So let here n is equals to 7, then omega string will be 0 0 0 0 0 0 0. So suppose we take x is equals to 0 0, y is equals to 0 0 0 and z is equals to 0 0. So x y to the power k z will be equals to 0 0 0 0 0 power k 0 0. So if k is equals to 1, then 0 0 0 0 0 0 0 belongs to that language. But if k is equals to 2, then 0 0, here what will be the language? 0 0 0 0 0 0 and here z. This belongs to that language or not? No, this does not belong to that language because these are not prime numbers. So language is non-regular. Now move to the next. Suppose if 0 2 plus 3k, where k belongs to n. So what will be the language? Suppose if k is 0, suppose because k belongs to n and n is 0, then 0 0, k is 1, then I am writing like this: 0 to the power 5. If k is 2, then 0 to the power 8. If k is 3 belongs to n, n is 3, then 0 to the power 11. Next 0 to the power 14, 0 to the power 17, like this the language will be. So suppose we choose n is equals to 8, then omega is equals to 0 0 0 0 0 0 0 0. So if we choose x is equals to 0 0 and y is equals to 0 0 0 and z is equals to 0 0 0, then x y to the power k z we write like this. So suppose if k is equals to 1, then what will be the language? The language will be, we write like this: x 0 square, y 0 cube, z 0 cube belongs to that language. But if k is equals to 2, then it will remain same x, then y will be 0 to the power 6 and z will remain same. Then this belongs to that language also, because 6 plus 3 plus 2 11, 0 to the power 11 is present. So if k is equals to 3, then what will be there? 0 to the power 2 for x, for y 0 to the power 9, for z 0 to the power 3. So 12 13 14. 0 to the power 14 is also present here, so this also belongs to that language. So suppose if k is equals to 3, then 0 square and 0 to the power 12 and 0 to the power 3. This also belongs to that language, 0 to the power 17. So this language is regular. This language is regular. So here are few important points. What they are: if there is no pumping element, that is y, then language is non-regular. What does it mean? Pumping element, I am saying y because we always choose a loop or thing by which we can change the language, and we can see if we are doing some changes in the y, then this also belongs to that language or not. That's why we are saying pumping element as y. And another important thing is, what is this? If language is non-regular, then we can take any element in y, and the selection of y will not interfere in our result, that the language will not become non-regular because language is already non-regular. The next thing, on behalf of this, suppose if we choose wrong y, or we can say pumping element. If we choose wrong pumping element, then proof of proving that language is regular or not will become false. That's why the choosing of correct y is very important in pumping lemma.